The Gauss-Jordan elimination form is quite similar to the Gaussian elimination form, and the only difference is that all the zeros occupies uh, all the slots in the matrix, 3 by 3 matrix, uh, up and down of this diagonal here, the leading ones, no? And your answers in the augmented matrix relationship like this, no? X, Y, and Z, no? Divided by this broken line here. So we have one sample problem here. The system of equation x plus y plus z is equal to 7, 2x minus y plus z is equal to 9, 3x minus z is equal to 10. First thing that we're going to do is just copy this one and rewrite this in the augmented matrix form here. So we just copy the coefficients here. 1, 1, 1, 7, no, this one, 1, 1, 1, 7, 2 minus 1, plus 1, 9, no, 2 minus 1, 1 and 9, 3, and replace the y here for 0, no? And then negative 1 and 10, no. After this, we go on now in the operations in the row echelon. So the first thing that we're going to do, we add row 1 and row 2, and we write our answers in row 2. No? So we add row 1 and row 2. So 2 plus 1 is 3. Negative 1 plus 1 is 0. 1 and 1 is 2. 9 plus 7 is 16. So the other rows, no, you just copy the other rows. No? Next is we're going to add row 2 and twice row 3. No? This row 2 and twice row 3. No? So this one, 3 plus 6 is 9. So this one, row 2, just add. So our answer is 0. Row 2 plus negative 1 times 2 is 0. Row 2 is 16 plus twice of 10 is 20. 16 plus 10, 20 is 36. We now have here another form of the augmented matrix form. As you can see, the third row can be simplified. No? We just divide the third row by 9 or multiply it by 1 over 9. So 9 divided by 9 is 1. 36 divided by 9 is 4. So we now have here the answer, no, for that operation. Next thing, as you can see, this row 1 and row 3, no? Row 3 here is the answer for our x. So we just, again, no? We continue, no? Our operation. Tries row 3 here, tries row 1. So 3 times 1 minus 2, no? 3 times 1 is 3. Minus 3 is 0. 3 times 1 is 3. Minus 3 is 0. 3 times 1 is 3. Minus 2 is 1. 3 times 7 is 21. Minus 16 is 5. So next thing, no? Since we have here the answer for x, not for the row 3, we just interchange the position or the rows 3 and row 1. So we're going to get this one here, no? So this one here, 1, 1, 1 occupies row 3, no? Next, we're going to subtract row 3 and row 1, get the difference of row 3 and row 1. So 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 0 is 1. 7 minus 4 is 3. And then we subtract again row 2 minus row 3 and write the answer in row 2. No? So row 2, 3 minus 1 is 2. And row 2 is 1 minus 1 is 0. 5 minus 3 is 2. So we have here 1, 0, 0, 4, 0, 2, 0, 2, no? And then we can simplify row 2 here by multiplying this one by 1 up or dividing this one by 2, no? So we have here, after dividing this row 2 here by 2, we get 0, 1, 0, 1. And then we just copy all the other rows, no? 1, 0, 0, 4, and 0, 1, 0, 1, no? And the only thing that is left here is row 3, no? We have 1, this should be 0 here. So to get this one to 0, to convert to 0, we just subtract row 3, subtract row 2 from row 3, no? So 1 minus 1 is 0. 1 minus 0 is 0. 3 minus 1 is 2. So as you can see, we have now this form here, as we have discussed lately, no? So this one, our answer now is 4, 1, 2, no? Back substitution, we get here, x will be 4, 1 is the value of y, and 2 will be the value of z, no? So we're just playing with numbers, no? And it's easy if we are to get this one, to perfect this one, just keep on practicing mathematics, no? This Gauss-Jordan elimination. And we're going to solve any problem involving any variable, any number of variables for the system of equations. So thank you again for watching our videos. And please don't forget to subscribe and send in your suggestions so as we can improve our way of presentation. So thank you and see you again later.